Today we're going to be talking about intermolecular forces. Intermolecular forces are the force of attraction between molecules. They can be used to explain a lot of different properties, such as boiling and melting points, solubility, volatility, and surface tension. There are three types that we're going to be looking at: London dispersion force, a dipole-dipole force, and a hydrogen bond. I want to emphasize that these are different than the force of attraction in molecules, which are the bonds. If we look at a molecule that you see on the screen, that line is representing a bond. That is what is called an intramolecular force, a force in the molecule. However, if you have two neighboring molecules near each other, there will be a force of attraction between those two molecules. This is an intermolecular force. Notice again that an intra is within the molecule and an inter is between molecules. The first type of force that we're going to talk about is a London dispersion force. This is the weakest of the three forces and is due to the random distribution of rapidly moving electrons that create temporary dipoles. This temporary dipole then induces a temporary dipole on another molecule or atom, which creates an attractive force. So if you imagine that we have a molecule like the one you see on the screen, and those negative marks are representing electrons, it is possible that at one point in time, all of those electrons are on one side of the atom than on the other. If that's true, then what we have is an uneven distribution of charge, which is going to create a region of a partial negative and partial positive. This is a temporary dipole. Now, if that molecule is near another molecule or atom, what it's going to do is that it is going to induce a temporary dipole on the other. So notice that the positive side of one molecule is going to be pulling the electrons of the other one near it. This is going to create an electrostatic attraction between molecules, which is called a London dispersion force. This is the main intermolecular force in non-polar molecules. All molecules do, however, exhibit this to some degree. Just a lot of the time in molecules that are polar, these forces are fairly small compared to the other predominant ones, which we will talk about in just a minute. A couple things to think about when we're comparing two molecules that have London dispersion forces. The larger the molecule or atom, the stronger the London dispersion force it can experience. And this is because when an atom or molecule is larger, there are more electrons. This will create a greater distribution of charge and therefore a stronger attraction. Some properties for molecules that have London dispersion force: they have relatively low melting and boiling points. That is because these force of attractions are very easy to separate and to weaken. They have high volatility. What this means is that they easily move from a liquid to a gas, or they evaporate fairly quickly. They also have low surface tension. Things can kind of move through the surface of the liquid fairly easily. Another type of force that we have is a dipole-dipole force. I kind of like to think of this as the middle child of the intermolecular forces. It is stronger than the London dispersion force, however, it is weaker than the hydrogen bond, which we will be talking about. Now, unlike a London dispersion force, which is a temporary dipole, a dipole-dipole force is from the permanent dipoles on polar molecules. So if we have a molecule that consists of a carbon-chlorine bond, and again, this isn't a whole molecule, this is only part of a molecule, we could see that on the chlorine side of the molecule, it would have a partial negative, and on the carbon, it would have a partial positive. These are not temporary dipoles. This is, on the other hand, a permanent dipole. So what we would see is that the oppositely charged sides of the molecules or of the bonds will be attracted to each other. This is the main intermolecular force in polar molecules. The larger the difference in electronegativity between the atoms, the greater the dipole, which means that the force of attraction would be greater. So when we think of the two atoms that are on either side of the bond, if the difference between those two molecules is large, it is going to have a larger dipole-dipole attraction. Molecules that experience dipole-dipole force will have higher boiling and melting points than those of our London dispersion forces. They are lower in volatility, and they have slightly higher surface tension. Hydrogen bond is the strongest of all the forces. This is a super strength dipole-dipole force that occurs when a polar molecule has a large electronegativity difference. If we look at these water molecules, we see that a water molecule has the positive region and the negative region within the molecule. These oppositely charged sides of the molecule, or the poles of the molecule, will be attracted to the opposite in a neighboring molecule. Now, what makes a hydrogen bond different than a dipole-dipole? It is the main intermolecular force in molecules that have a hydrogen bonded to a fluorine, a hydrogen bonded to an oxygen, or a hydrogen bonded to a nitrogen. So in order for a molecule to experience hydrogen bonds, it must have one of these three bonds and it must be polar. The reason why it's these three bonds is that these three bonds have a greater electronegativity difference than most other bonds. So the more hydrogen-oxygen or hydrogen-nitrogen or hydrogen-fluorine bonds that are in the molecule, the stronger the hydrogen bond. If we were to think about their properties, these would have the highest boiling and melting points, the lowest volatility, and the highest surface tension. So how do we actually identify the type of intermolecular force? Here on the screen, I have a kind of chart that we could think about, or a mind map to help us think about what type of force a molecule would experience. The first thing you want to think of is the molecule polar or nonpolar? If the molecule is nonpolar, it will only experience London dispersion force. If the molecule is polar, then you need to ask yourself another question. Is there a hydrogen bonded to an oxygen, bonded to a nitrogen, or bonded to a fluorine? If the answer is no, then it is going to experience predominantly dipole-dipole forces. However, if it does have one of these three types of bonds, it will experience hydrogen bond as the main one.